Hello, hi, good morning, my students. So, in the yesterday class, we have continued the SHE, means she. SHE is nothing but standard hydrogen electrode. By using this SHE, we can able to calculate we can able to determine the another rod, means another electrode's potential difference we can able to calculate. So this is the reason why we are calculating, why we are using the SHE. Means SHE is having initially the electrode potential of SHE is considered as 0, means arbitrarily it is considered as 0, means its potential value, electrode potential of SHE is considered as 0 whenever it is connected to the thing that this is SHE rod, electrode, it is connected to the another electrode, it is unknown, it is SHE, means it is dipped in one beaker and it is kept in another beaker. These are connected here and it is connected to the battery, and something will be there, resonance, plug key and the voltmeter, everything will be there. So here the reason is the SHE, here the electrode potential of this SHE is considered as 0. It is having the value 0. How much the voltage here this value generating? The total value, it is the value of this unknown electrode potential. It is the value of this unknown electrode potential. This is the meaning how we are calculating the electrode potential of another electrode by using the SHE. And one more, if it is SHE is connected to the anode, then the value appearing is positive EMF. Then we are going to get the EMF of the another cell is positive. If SHE is connected to the cathode, then we are going to get the EMF of the unknown electrode as a negative. This is you have to remember. Means to obtain the electrode potential of unknown, if we want positive, means we have to keep the SHE at anode. If we want this unknown electrode potential as a negative, then we have to keep this SHE at cathode. Means at anode we have the another unknown electrode potential. It means that it is not in our hand to calculate the electrode potential positive and negative. But we are already, it is our scientists have discovered the actual value of each of the metal is having its own electrode potential value. For example, today we are going to calculate the determination of standard electrode potential of zinc. Can you see here? E is nothing but electrode potential. E naught, if I write 0 means power 0 means it is called as E naught. Means standard electrode potential of zinc. Simply EZL means electrode potential of zinc. Means don't know the potential, that is called as electrode potential of the zinc. E naught is indicates the standard electrode potential of the zinc. Here we are going to calculate the determination of standard electrode potential of zinc by using SHE, by using standard hydrogen electrode. Look here, I am telling you the truth is zinc electrode potential, I know that it is a negative value, whereas copper is going to have the positive value. How? Because in the Daniell cell, I hope you remember, the zinc is connected to the anode, means it is going to carry the negative charge, isn't it? The copper is connected to acts as a cathode, it is having the positive charge there. So here always the zinc should have the negative charges. Negative charge means it should have the electrode potential as a negative. For that reason, to have this negative value, EMF I should bring as a negative. It means that I have to keep this SHE in cathode, SHE in the cathode. Are you getting my point? So I know already the zinc in the Daniell cell, zinc is going to carry the negative charge and copper is going to carry the positive charge, isn't it? So make it as a zinc as a negative value. To make the EMF as a negative value, I am going to keep SHE as a cathode. So when the SHE is connected to the cathode and unknown zinc electrode is connected to the anode, whenever it is connected, whatever the EMF we are observing here, SHE, it is connected to the cathode. Means it is not only E cell, you have to write E naught. Standard electrode potential of the cell can be calculated as by the difference of standard electrode potential of cathode minus standard electrode potential of anode. So here at cathode, which one we have kept? At cathode we have kept as a reference electrode. Reference electrode we have kept. What is that reference electrode? The reference electrode is nothing but the SHE minus standard electrode potential of another one is at anode we have kept as a zinc, that is zinc. Let's look here. Reference is nothing but it is electrode potential of SHE minus electrode potential of the zinc. So whenever it is connected, SHE is connected to the cathode and zinc is connected to the anode, the voltage appeared, the potential difference appeared is minus 0.76, means it is simply the 0.76 volt. 0.76 volt. Now I am going to write this electrode potential of zinc, means standard electrode potential we are going to calculate here. Look here. Standard electrode potential of the zinc is considered as 0 because it is initially considered as in arbitrarily the value of SHE is considered as 0 voltage minus the zinc is going to carry the value 0.76 volt. So 0 minus 0.76 means overall value is minus 0.76 volt. This is the electrode potential of the zinc rod. Electrode potential of the zinc rod. So it means that we have made some mistake here. Can you see here electrode potential of the zinc here? But whichever we have obtained the electrode cell, this is the E cell, E cell. But here we have to convert this one. Look here. We need zinc value, so that zinc we are taking this here. Electrode potential of the zinc, standard electrode potential of the zinc, and E cell remains as it is. Remains as it is. E cell not it is moved to this cell. This plus becomes minus E cell not. Means how much the electrode potential we are observed here? 0.76. It is E cell not. 0.0. This is SHE value minus the observed value is 0.76. Therefore, the standard electrode potential of the zinc is minus 0.76 volt. Minus 0.76 volt. Look here, they will ask you determine the or calculate the standard electrode potential of the zinc by using SHE. If they ask like this, means you have to write some words, which one I have given in the notes. Here, the reference electrode is used as SHE. Reference electrode is used as SHE, which is having the potential difference as 0 voltage, and this SHE is connected to the cathode and the zinc rod is connected to the anode. So together the observed electrode potential value is 0.76. To calculate the potential difference of zinc, we are having the formula E cell rod minus E cathode minus E anode. So here cathode minus anode, cathode is nothing but reference, that is cell SHE, and anode is nothing but zinc. We need zinc value. How much zinc we have observed? Total potential is this one, E cell not. We are sending this zinc to that side, this minus becomes plus, and E cell not we are taking to the right side, this plus becomes minus E cell not. SHE value is 0, E cell not value observed value is 0.76 in the experiment. Here minus as it is 0.76. 0 minus 0.76 is overall minus 0.76 voltage. This is the standard value of zinc. Whenever we are using the zinc as an electrode, that zinc electrode is having the potential difference, means electrode potential of the zinc is minus 0.76 volt. This is fixed value, it is not having any changes, means it is experimentally determined value. Are you getting my point? This is about the determination of zinc, standard electrode potential of zinc by using the SHE. I hope you can able to understand this one. SHE and we are connected to the another compound, so that we are able to calculate. Here we need the zinc value as a negative only. For that reason we are connected SHE to the cathode. SHE to the cathode. That's why we have obtained the zinc value as negative value. Are you getting? The next one is determination of copper. At that time we are going to change the copper wire. We need positive value so that we are connecting SHC to the anode. So we will move the next one. Before that we will write some of the reactions, how the reactions are taking place at anode and cathode. Look here, in this one the zinc is connected to the anode. At anode always it undergo the oxidation. Why? Because you are familiar about the Daniel cell. At anode it's undergo half reaction. Zinc undergo oxidation. Therefore at anode zinc is formed as a zinc plus 2 by loss of 2 electron. Similarly at cathode, here at cathode we are connected the SHC. SHC is nothing but here we are going to show that hydrogen ions. So hydrogen ion is going to receive the electron to form the half H, isn't it? Together, to make it as a balance, 2 electrons are there. Therefore, we will multiply by 2. Therefore, we are going to get 2H plus 2 electron, and 2 into 1 by 2, it becomes 1. Are you getting this one? So next one, overall reaction is 2 electrons are cancelling, and remaining is zinc plus 2H plus, it's going to form as a zinc plus 2 and plus H2. Can you see here? The charge of zinc is 0. Zinc 0 to zinc plus 2 means zinc undergo oxidation, whereas hydrogen initially it is in the form of plus. It is going to receive the electron and it forms the oxidation state is 0. Means SHC undergo the reduction and zinc undergo the oxidation based on this anode and cathode. This is the reaction taking place at anode and cathode. At anode it is called as half oxidation reaction, half reduction reaction. Together it is called as redox reaction. It is the overall reaction. So this is about the determination of standard electrode potential of zinc by using SHC. The same we will be continuing in the next one, copper. The cell representation for the calculation of zinc rod is to get zinc standard electrode potential of the zinc we have calculated by connecting this to the SHC. Here zinc is connected to the anode, SHC is connected to the cathode. Means we have to write the cell representation from anode to the cathode, because at anode it undergoes the oxidation. First we have to write the oxidation, next we have to write the reduction, isn't it? You have to remember this one. The cell representation for the determination of standard electrode potential of the zinc is, look here, initially zinc rod is dipped in a zinc solution. The charge of the zinc is in the solution, it is plus 2, and it is connected together. It is zinc solution is connected to the SHC by Salt bridge, and this solution SHC, the ion present is hydrogen ion. That hydrogen ion is undergo the gaseous hydrogen gas. That hydrogen gas is going to deposit on the platinum surface, which is solid, hydrogen gas which is a gas, H plus which is aqueous, having the concentration 1 molar concentration. This is the cell representation while determining the standard electrode potential of zinc. It means that when zinc rod is connected to the SHC at that condition, this is the cell representation. Commonly we can call this as zinc and hydrogen cell. Zinc and hydrogen cell representation is zinc rod dipped in zinc solution and Salt bridge, hydrogen ions which is generated by the hydrogen gas and deposited at platinum. Whenever we are writing the SHC, we have to write the SHE at rod, means electrode metal is platinum. Why? Because in the SHE, the metal used for the oxidation and reduction is the platinum surface is used. So coming to the next one, look here. Determination of standard electrode potential of copper by using the SH. Same thing as we did in the previous. Here also we are going to calculate the standard electrode potential of copper. We are connecting the SHE. We are connecting the SHE to the copper. In this condition, what happens means we are using the copper and we are connecting SHE. Here we need copper as a positive value. Positive value means EMF of the copper we need as a positive. For that condition, we are going to connect the SHE to anode. To the anode, we are going to connect as a SHE. So we are connecting copper electrode to the SHE. How much the voltage we are generating? That voltage will be calculated by this formula. That value will be the value of copper. So let's see here. So in the determination of standard electrode potential of the copper, we use it as a SHE, where SHE is standard hydrogen electrode. It is used as a reference electrode and it is considered as the potential, electrode potential of the SHE is considered as 0. To determine the value of standard electrode potential of the copper, we are going to connect the SHE at anode. Why? Because we need the EMF of copper as a positive value. For that reason, we will connect SHE to anode so that we can get the positive of the EMF of copper. Let's see here. After connection this one, we are going to get the standard electrode potential. The voltage appeared is in this copper and SHE is 0.34 volt. This is 0.34 volt. Let's see here. Standard electrode potential can be calculated by the difference of cathode minus anode. Here, electrode potential at cathode. At cathode, which one is present here? At cathode, copper is present. Means copper, electrode potential of the copper minus electrode potential of the anode. Here, anode is nothing but what? It is SHE. At anode, we are connected the SHE. So now we need the value of copper. So let's send this SHE to the right side. What happens? E copper, standard electrode potential of the copper. I am sending this to the right side. Means E cell naught becomes as it is, minus become plus E SHE. Got it? Look here. The observed value of electrode potential of the cell is 0.34 voltage. 0.34 voltage plus the standard electrode potential SHE value is 0.0 volt. It is 0.0. So by adding these two, we are going to get again 0.34 volt. This is the potential, electrode potential of standard copper. Therefore, standard electrode potential of copper is having the value positive. It is positive 0.34 voltage. This is fixed value. So as we have observed in the previous zinc is having the electrode potential minus 0.76. The zinc always, whenever you are observing, you are taking the value in the problem or anything while observing, zinc is having fixed 0.76 value only. Zinc value is fixed. Similarly, the standard electrode potential of the copper is also fixed. The value of copper is always 0.34 voltage. You have to remember this one. No doubt in the theory you are not having usage of this one. Why? Because this time you are not having any numerical problems to solve. Why? Because it is reduced. But anyhow, in the competitive exams, these are necessary. You are going to have the applications and problems based on this electrode potential of copper, zinc and some other SHE you are going to use. Therefore, this is important for your competitive exams. This is about the determination of electrode potential of the copper. You have to remember how we have connected and how we have obtained this 0.34 means you are connected SHE to the anode and it is considered as 0. And when the SHE is connected to the anode, then the another electrode can be obtained. The EMF value is positive value. So here the overall reactions overall reaction means the reaction at anode. The reaction at anode. So I say in every reaction or in every construction at anode it has to be undergo oxidation, at cathode it undergo the reduction. Look here, at anode is nothing but it's undergo the SHE. So SHE is nothing but it's undergo the hydrogen's ion. Hydrogen, it should undergo the ions, half ions, and it's going to form as H plus by loss of electron. If it is loss of electron, then it is called as oxidation, means zero charge it formed as a plus 1. Similarly, at cathode, cathode is nothing but it is undergo the copper. So copper is undergo reduction. Initially copper it is in the form of plus 2. By receiving 2 electron, the copper is undergo neutral. So now we will do the multiplication for this first one. Why? Because here gain of electrons by the copper is 2 electrons. Here loss of hydrogen is 1. Therefore, to make it as an equal, we will write this equation once again. 1 by 2 into 2, it becomes H2. 2H plus 2 electron. So now we will cancel. At the left side in the reactant we are having 2 electrons. Here in the product right side we are having 2 electrons. So remaining overall reaction is This is the reaction called redox reaction. This is half of oxidation. This is half of reduction. Together it is called as redox reaction. The remaining is copper plus 2 charge plus neutral hydrogen, and it's going to form as a copper plus 2H plus. Can you see here it is balanced? Copper plus 2 is undergo the 0, means copper undergo reduction, hydrogen undergo oxidation. This is called as complete redox reaction. Sometimes you may have a question like this: write the reaction taking place at anode and cathode in the SHE and copper, means when the cell rod is connected to the SHE and copper. So at that time you have to capable to write the reactions here. Similarly, you may have the questions like this: calculate or determine or calculate the standard electrode potential of the copper by using SHE. If they ask like this, means it will be asked for 2 marks, 2 to 3 marks. Write the some explanation and begins to calculate, and up to here you have to write. And if you have written this one, means it will be a better one. And along with this, the representation of cell is also important. Look here, the cell representation. Here in the cell, I say you always you have to begin from the anode. Anode first you have to write, and next you have to write the cathode. Why? Because at anode oxidation takes place. First you have to write the oxidation, next one is reduction. In the anode we are having the SHE. In the anode we are having SHE. First we have to write the SHE. So in SHE we have to begin from the rod. The rod present is platinum. Platinum rod, which is solid. It is undergo the ions. Which gas is deposited? Means hydrogen gas. Here hydrogen H2. It is gaseous compound which is generated from the electrolyte. The electrolyte is nothing but what? H plus. Here H plus is in the form of aqueous. It is having the concentration 1 molar. Are you getting this one? This is the cell representation of SHE. Zinc rod means platinum rod having the surface of hydrogen surface, means the platinum rod containing the hydrogen gases, and those are obtained by the hydrogen ions, that is HCl. It is connected to the cathode, means copper, through a salt bridge. The ions present in the copper rod is copper ion, which is in the form of plus 2. That ions are, means electrolytes are contained in the electrode, that is copper. See, have you understood this one? This is the cell representation of hydrogen gas and copper cell. write the cell representation of hydrogen and copper cell. Means hydrogen, if they have given, means it is understood. Hydrogen, you can't write that hydrogen is itself is a SHE. SHE is considered as hydrogen because hydrogen can't write, but we have to write the platinum also. Platinum rod, hydrogen gas, hydrogen ion, which is salt bridge connected to the copper. So here oxidation taking place is SHE. That's why we have written from the platinum and it is salt bridge. In the previous, that is in the zinc, we have written first zinc we have written because zinc undergoes the oxidation. Next we have written as a H plus H2 and platinum. Why? Because it is reverse. Rod, electrolyte, salt bridge, then again electrolyte and rod. Are we getting this one? Here it is SHE, rod is platinum, hydrogen ions are depositing, present is electrolyte is H plus ion. It is connected to the salt bridge, double line, and the ion present is here is copper ions plus 2 and rod present is copper. So do remember this one, don't try to by head or practice this one, practice, but by understanding this one is a better way. Sometime if they ask a different cell representation, you should be thorough to write this one. So we will see the same continuation of the concepts in the next class. If you are having any doubts, feel free to ask. We will see the continuation in the next class. Okay, have a nice day. Bye.